Okay, students, we're going to go over Mod 4 Topic 1 test, practice test here. It says rectangle ABCD is rotated about its side AB. So you're going to rotate about this right here. Rotating, boom, over and over. That creates a cylinder that you've seen in class. The volume of a cylinder is pi r squared h, which is the area of the base, which is a circle, times the height. Okay, so 5 is my radius, so fill it in there, and the height is 13. So you have 25 times 13 is 325 pi cubic inches. Notice it left the answer in exact answer with pi in it. 2, what action could you use to create the following object? You stack similar squares, means they get smaller and smaller, and then it creates the pyramid, square pyramid that is. Okay, 3, shaded circle is a great circle. The great circle means it's the longest radius, okay, going through the center of the circle. Okay, it's called the great circle. What's the diameter of the sphere? Okay, notice that points to right there, which only goes from there to there. That's the radius. It wants the diameter, so diameter is 2 times radius, 14 feet. Number 4, circle with a central angle 15 degrees has an intercepted arc of 5 pi over 4. Just write that a little bigger. Inches, what's the radius of the circle? Okay, so the arc itself from there to there is 5 pi over 4. Well, we know we calculate that by doing the degrees, which is 15 degrees over 360, because that's the whole circle. So that's the fraction, 15 3/60ths. The distance around a circle is the circumference, and that formula is 2 pi r. Okay, and that distance, that fraction, the 15 r 360, is equal to 5 pi over 4. So now we need to solve this for r. Okay, so we'd have 15 times 2 is 30 over 360 is 1/12. That's the 1/12 r right there. The pi's cancel, by the way. Okay, so I have 1/12 r equals 5/4. How do I get rid of the 1/12? Multiply by 12 on both sides. So they cancel, you get r equals 15. And then the units were inches, so 15 inches. Number 5, what's the approximate volume of the sphere? Volume of a sphere is 4/3 pi r cubed. So we need the r, and it even tells us the r, 13. So just fill in the 13 right there for r. Type it in. Notice I left pi in the answer, so I just do 4/3 times 13 cubed, and that gives me 29. Yep, 29 pi. 29 pi. Angular velocity. Okay, angular velocity right here equals the change in theta. Theta is in radians. Okay, so it's got to always be in radians when it says change in theta. There, over the change in time. Remember, that's change, subtraction. Well, they gave us both those. Rotates 7 pi over 2 radians, so it's already in radians. So that's the amount that it changed in the theta over 24 seconds. So now I just divide that. Division by 24 is the same thing as multiplying by 1/24. It's reciprocal. So I get 7 pi over 48 radians per second. C. Number 7. A cylinder has a radius of 4.5 inches and a height of 12 3/4. Okay, what's the approximate volume of the cylinder? Okay, volume of the cylinder, again, pi r squared h. They give me the r, 4.5. I'd have changed it to improper fraction, but you could have just left it as 4.5 squared. That's what 9/2 is, and 12 3/4 is 12.75. That's why I changed it to a decimal. And notice they did not leave pi in the answer, so that means I type in this entire thing into my calculator, and it's like 811, so it's close to 810 right there. Number 8, circle E has a shaded segment as shown. Measuring angle DEF is 90 degrees, so that's 1/4 of the circle. That's where this 1/4 comes from right there. 90 over 360 is 1/4. What's the area of the shaded part of the circle? Let's call it a segment. So I find the area of the sector is the whole thing, and then subtract off the area of that isosceles triangle. Remember, we know it's an isosceles, right? Well, isosceles triangle right there. And since that's 90 degrees, then it's a 45, 45, 90. Okay, and that would give me the area of the segment. That's called a segment between the, okay, right there. So area of the sector itself will be 1/4 of the 90 over 360 is 1/4 pi r squared. Okay, that's the area of the whole thing, and the r was 6 right there. So fill in 6, 36 divided by 4 is 9 pi. And then I have to subtract off, that's 6 and that's 6. So area of a triangle, remember, is 1/2 base times the height. So 1/2 of 36 is 18. So 9 pi minus 18 square inches because it's an area. Number 9, square pyramid has a volume. Pyramid is always 1/3 area of the base times the height. That's a general equation. And it tells me what the volume is, so I set that equal to 132. Has a height of 11, plug in that, and it's a square pyramid. Okay, so the area of a square, which is the base, is sides squared. Has a height of 11, so I put 11 in for the height. So I go ahead and multiply by 3 on both sides, and then divide by 11, and I get 36 equals s squared. Take the square root of both sides. And s is 6 because it can't be -6. No negative distance, so you drop off the negative. So 6 centimeters. Go back and find the centimeters right there. Okay, 10. We want to find the area of this cone. It says 80 degrees. That's 80 out of 360 again. That's the fraction. Pi r squared, and it told me r was 0.9. So I do 0.9 squared times 80 divided by 360, and I get 0.18 pi. Right there. 15, which of these arc lengths is the longest? So remember, it's the degrees over 360 each time. So 30 over 360 is 1/12. 45 over 360 is 1/8. 60 over 360 is 1/6. And then 2 pi r. We're talking about arc length. So it's circumference. 2 pi r, 2 pi 12, 2 pi 10, and 2 pi 8. And we get those answers. Okay, then you have a 2 pi, you have a 2.5 pi, you have 2 2/3 pi, and you have 3 pi for the last one. So that's the longest, is 3 pi. Calculate each one of those so you find the longest. Triangles rotate along its center to form a three-dimensional solid. Which dimension of the solid relates to the base of the triangle? A triangle is rotated about this. Okay, I just sneezed there. All right. A triangle is rotated along its center okay, to form a three-dimensional object. Which dimension of the solid relates to the base of the triangle? This right here, when I rotate it, okay, that's going to deal with this diameter of the solid's base, right? It's going to be a circle, so it'd be a pyramid cone there, be a cone, okay, and so that deals with this diameter, okay, which is why, remember, diameter is dealing with a circle. All right, 12, we want to find the area of the shaded portions. Okay, well, I can go ahead and do the area of the entire circle minus the area of that triangle. Told me the radius was 4 feet. That's why you see the 4 there and there. Okay, so pi r squared is 16 pi. That's the entire circle. Now I have to subtract off the area of the triangle. 1/2 of 4 times 4, 1/2 of 16 is 8. So subtract off 8. And there you go right there. 13. A student translates an isosceles triangle right here diagonally. Okay, so you get back to that right there. Okay, and it's asking, what's the shape of the lateral side right here? Okay, those are parallelograms. Okay. 14, cross section. Okay, I fill in the numbers. AC is 6, BC is 4. Since BC is 4 and AC is 6, that means that right there is 2. The length of AE, the arc AE is pi. What's the measure of arc BD? We want to find that right there. Well, it's going to be proportional. Okay. So what do we have? The whole length would be 6 over the inner one is 4. This arc length is pi. 6 goes along with the outer one. So this is outer, outer. This is inner, and this would be inner down here. And the inner one is x. We don't know what it is. We're trying to find that arc length. So what you have here, I just reduced it down to 3/2. 6/4 reduced to 3/2. Then I cross multiplied. Okay, so you get 3x equals 2 pi, divide by 3 on both sides, and you get 2/3 pi. C. Did I hide 15 somewhere? Where did I put 15? Was 15 on the last page somewhere? Oh, here's, oh yeah, I already did 15 right there. Okay, 16 now. What shape can you rotate around the x-axis to form a cylinder? All these are form cylinders. The only question is the right ones with a radius of 4 and a height of 10. Select all that apply. Remember, we want it around the x-axis. So there's my radius, 4 right there. There's my height, 10 right there. Remember, select all apply is going to tell you it's probably 2 or 3. There again, I'm rotating. So this is just the full length right there. Doesn't matter, it has that, it's still going to rotate around the x-axis, the same thing. So radius is 4 and height is 10. So those two right there. Which of the following pairs of angle measures describe the same angle? So remember, pi equals 180 degrees. So when it says pi over 3, that means there's pi over 3. So 180 divided by 3, that is 60. So that's true. Pi over 3 equals 60 degrees. Pi equals 180. Okay, pi over 5. So that means divided by 5. Pi over 5 would equal 180 divided by 5, which is 36 right there. Okay. This was pi over 4. Okay, so that'd be 180 over 4, but that's only 45 degrees, not 90 degrees. Okay, and pi we already said was 180 degrees, not 360. 18. Which arc length is equal to 2 pi? Okay, so again, arc length is the degrees over 360. 270 over 360 is 3/4 reduced. 2 pi r. So there it tells me the r. I fill it in, and I get 6 pi. It wants it to be 2 pi, so that's out. 120 over 360 is 1/3. Okay, 2 pi r. So 6 cancels the 3 2 times. 2 times 2 is 4 pi, which is not equal to 2 pi, so that's out. 45 degrees is 1/8 pi. I mean 1/8 of the entire circle. Okay, times 2 pi, and r was 8 there. The 8's cancel, and you're left with 2 pi. So that's true. And then the last one, 36 over 360 is 1/10. 2 pi, and the radius there is 10. The 10's cancel, and I get 2 pi. So it's C and D. 19 says right cylinder has a base area. Volume would be area of the base times the height. And it says the base area is 16 pi. Okay, with the height of 8, 16 pi times 8. Okay. Which shape has the same volume as the right cylinder? It says volume multiply that out. 8 times 16 is 128 pi. So we're going to go and calculate these ones and see which ones also give you 128 pi. Okay, A does, you got pi r squared h. So 2 squared times, which is 4 times 32 is 128. So A works. B, an oblique cylinder, still pi r squared h, radius of 4. So you got pi r squared, 4 squared is 16 times 8. 16 times 8 is the same thing, so that works. A cone, remember at the base area, a cone is 1/3 area of the base times the height, so 1/3, and it says base area is 16 pi, and the height is 24. So the 24 cancels with the 3. 8 times 16 is the same thing as the 128. Okay, and then the last one didn't work. And lastly, number 20, a square is inscribed in a circle as shown. Which statement is true? Select all that apply. The areas of triangle ABC and ADC are not equal. Well, of course they're equal. It's a square. Okay, the measure of arc AB equals the measure of arc BC, which equals the measure of arc CD, which equals the measure of arc, yes, because they're all going to have the same right there. They're all 90 degrees right there. So the central angle equals its arc measure. So they'll all be 90 right there. So that's true. The area of the shaded region is equal to the area of triangle ABC. We'll do that one last. Segment AC is congruent to segment BD. Yes. On a square, we know the diagonals are congruent. Okay. Now, over here is where I did the work for doing B. So if I want the area, it says the area of the shaded region, which would be the entire circle, pi r squared, okay, minus the area of the square. Okay, the area of the square, so it didn't give me a number, so I just went ahead and filled in a square, made it 2 and 2. Well, that makes the hypotenuse 2 root 2 because of 45, 45, 90, right triangle there. Okay, so now when I talk about the area of the square, that'd be 4. 2 squared is 4. Okay, so that's the -4 right there. Now, what's the area of the circle? Well, I do half of that, 2 root 2, to get the radius. Half of 2 root 2 is 1 root 2. So the radius is root 2. And it's pi r squared. So I got pi root 2 squared. Root 2 squared is 2 times pi is 2 pi. So I get 2 pi minus 4. Well, that does not equal 4. The area of the square is a triangle ABC. Oh, that's even less. Okay. Triangle ABC would be only 2. Okay, because the whole area ABCD, the square is 4, half would be 2. So those are not equal. Okay, that does it. 19 minutes.